Welcome everyone to the webinar talking about improving availability with plant asset management. While we just wait for everyone to join in, I'm just going to show you some things about the GoToWebinar interface if you haven't used it before. On the left-hand side of your screen, you'll see a box, and in that box there's a number of handouts. You can also type in your questions that you might have throughout the webinar in the box, and we'll collate those questions and then answer them at the end of the question and answer session towards the end. You can also make sure that your audio settings are correct there and have a look at any of the functions that you can see on the left-hand side. So my name is Taylor McCurdish. I'm the industry manager for mining, metals, oil and gas. And today's webinar is going to be presented by Christian Walter. And he is the Global Business Development Manager for Digital Solutions. Christian, I hand over to you now.
Thank you very much, Taylor. So welcome from my side. The next 25 minutes, I will show you a bit about our asset health monitoring solution, what it does, what's the value to our customers, how it works, and there will be a couple of slides at the beginning, a little bit explanation, and then we jump straight into live demo. So whenever you have a question, please ask in the chat, so we will try to answer them immediately. If it's a short one, if it's a bit longer one, we put it at the end of the question answer session, as we said. So we start with the overview. So what's the motivation about it? So the introduction a bit. So Endress+Hauser Digital Solutions, where I work for, is located in Switzerland. So actually I'm doing this COVID-19 based out of my home office here in Germany. But I work in Switzerland, in the border where all the three countries, Swiss, France, and Germany met. So the company is founded in 1999 and started up, be operational more or less exactly 20 years ago. At the moment, we have above 170 people focusing on software, IoT, and the topic that we're presenting today, which is asset health monitoring. So the hashtag here is empower the field. So using data from the field to do something useful with it and to gain some efficiencies. So what we're talking here about. So of course, you all have the primary measurement value that comes via the PLC or the DCS. But usually this is just a value. So if there's a problem, then you might get the failure current like 4 to 20 milliamp goes up to over 20 or below 4. And you can see, oh, there's a problem. But at that point, the instrument technically already quit. So the idea is to have a secondary channel to get additional data out of the field to be able to do more. So the basic is diagnostics, to get information from the device about the health status, what's going on, then to actually monitoring, and what's not used yet, what's basically in the development at the moment in the industry as such is prediction, predictive, soft sensing, to use continually data to make some calculations and assumptions. So with Endress+Hauser, since a while, we're developing our heartbeat technology, which is a standard for increased diagnostics, so the devices have more and more intelligence and self-checking functions that permanently monitor the status or the functionality of the device. So with that, we are able to move from a reactive maintenance concept, what we have today. Most of the time, so something is broken, you go and fix it, to a preventive, which is we take data and we try to avoid that it breaks. So that could be with fixed interval maintenance schedules, which is today most of the time the case. But it could also be that you only do maintenance when they're actually, the device tells you, I need maintenance. Or if, let's say, there is an interval of 3 or 4 weeks or month, and the device in that time already sees, hey, there might be a problem in a week or two, then maybe do something about it to avoid that you have a problem. And that will lead to the third one, which is predictive. We have a couple of applications at the moment where we are able to do that. So where we really have a counter and timers that based on algorithms and also a bit of artificial intelligence in the background that can then make a prediction in that application based on the process environmental conditions that device might have a problem or needs cleaning in that amount of days. Today's webinar is focusing on the first two. It's technically how to get information and how to take that information to move from a strictly reactive to preventive system. I compare this always like in your car. If you in the morning sit in your car, go to work, maybe at the moment with this situation, it's not that much, at least here in Europe, but I assume we're back to normal. You go in your car and the ignition is on, and then you can see, oh, there's a green light, which is usually everything is okay. There's orange light that tells you, okay, this is not normal, something needs attention, but usually it's not critical. And there's a red light, and there's a red light. This is typically, oh, watch out, maybe you have to fix it or bring it to garage to have a look at it. So we're following a similar concept. So what you see here is an example. This is from a customer side where we install the system, and in the first 5 minutes, we got a couple of these messages, or kind of these messages. So what you see here is a analytical instrument that tells that we are in a maintenance required diagnostic mode with that device. So technically, this device is still working, but it's a pH probe and it has a sensor drift. So a 0 point warning, and that means that 0 point is moving. And if that 0 point is moving over a certain threshold, the device will go in a failure mode because it cannot measure reliably anymore. So you can see here, we get the cause, 0 point warning, we still can measure the possible reasons. So we have an overaged or defect sensor, diaphragm is blocked, or the buffer solution is overaged. So what should we do? The remedy, please check the sensor, replace it necessarily, check the buffer, or repeat the calibration. That kind of information, most of the customers we talk to, they don't get this. It's in the device, it's in the field, maybe it's shown on the display, but there is no way where maintenance people or people that really can actually do something with it can see it and then can take actions. And that's what we address with our solution, to give the information to the right people that can actually do something with it in a very easy way. So what's the solution doing that we provide? So first of all, it continuously monitors and logs the instrumentation health status. And it makes that information visible in a very, you will see in the live demo, we think in a very easy way. It provides insight about the installed base, so you see what you have on site. So you also see if devices are disconnected or if new devices are connected. It works with all hard instruments, so absolutely independent from the vendor. So it doesn't only work with E&H. So you can also connect Emerson or Vega or Chrono or whatever you have on your site to that system. As long as it speaks hard, you will be able to monitor those devices as well. And if you have suitable sensors, so that's also a bit of depending on what hardware you have in the field, you can use the advanced features, as I said before, with heartbeat, with self-checking internal reports, audits, that you can, for instance, extend the calibration intervals. One important thing about the whole solution, it's 100% on-premise solution. That means it works in your network. It doesn't require any internet or cloud connectivity. However, as we as Endress+Hauser and the whole world is moving more and more to cloud systems, and in this crisis at the moment, you can clearly see the benefit of having such solutions in terms of access and work together. This is IoT ready. So that means with a very little effort in future, you would be able to switch also to include cloud services with it. So I will not spend too much time about the visualization, but the key point of the whole system is access, is ease of access. So we will see it's a web page. It's very easy to access, so you don't need a DCS or PLC expert nor access rights to the PLC or DCS to access that system. What is important, we're using the NAMUR NA107 standard. This is a standard that technically tells about the importance and the categorization of diagnostic messages coming from field devices. So there's a lot of messages coming from the field, and a couple of years back, the industry figured out it's not too less information, it's actually too much. So what's really important, what's not so important, what's more maintenance, what's more process related, and they came up with that categorization. So in a nutshell, there are 4 different status besides good. So all good is usually a green symbol, but there are 4 more, which is failure. This is the most critical one. So this is really a serious issue. Function check. So you have to have a look. Something is not normal. So that could be, for instance, an uncommissioned device. So before you do a full empty calibration or stuff like that, it could be that it's measuring accurately, but it's not correctly set up. So that's a function check. Then we have out of specification. So this could be a pressure transmitter, for instance, that's an overpressure, but still okay. So let's say set to 0 to 10 bar, but the cell can handle up to 20 bar. Then if you have 11, it will tell you, oh, I'm out of my specified range. And obviously maintenance required with a little oil can, which is, yeah, device needs maintenance. Good. The whole system, of course, works on premise with desktop stations, and we're also able to have a mobile solution. So I will get back to those details very soon. So to visualize a bit how it's working, what we're doing, we have a little animation that explains a bit, and I will just use that and explain you a bit the components. So we call this the Asset Health Monitoring Solution, SRP 700. So SRP is short for Solution Ready Package. It's a pre-engineered solution that we can install. So this is the overview, and this is we call it Rockwell Edition. So we can use Rockwell DCS systems because Endress+Hauser has a strategic alliance with Rockwell and work together. So Rockwell made it possible for us to go via the controllers and remote IOs. So from our system straight to the field. So you don't need any additional hardware to bypass any controller. We can also do this with Profinet or with Profibus. So we also have modules for legacy installation to put it in hard. We just here, as an example, visualize it with Rockwell. So, but we are open for other topologies as well. So the system actually consists of a couple of components. So first of all, the client is what you actually use as a user. So it's the end user access point. A client can be a desktop engineering station, can be a laptop, can be a virtual machine that's running with some terminal access. Let's say if you have a Rockwell system, you could also use these little terminals to access there. You can also use a mobile client, our SMT70 tablet, out of the box, fully integrated, works with the system that you can access it, so you can use it in the field and from a central point. KPI dashboards are a customized engineered solution on top of our standard offering to monitor KPIs, but the heart of the component, so the core, is the SRP 700, the Asset Health Monitor database and service, and the gateway. So they are actually getting the information from the field and making it visible to you. So the health monitor is collecting all the data from up to 10 gateways. So the gateway and the Asset Health Monitor can be on the same machine. In larger installations, it can also be on separate machines. So that, let's say if you have 10 gateways, you would have one Asset Health Monitor that comes with it. The whole system is capable to handle up to 10,000 tags. So every gateway machine is around 500 to 1,000 tags. It's a bit depending on how many tags are monitored and what frequency and what's actually also the hardware capability, the software capability of that gateway. So it's really easily scalable. So it works for small installations. We have very attractive offering for small sites with 100 tags, really up to 5,000 or 6,000 or more tags per install. You can also combine different systems in case you have even more than 10,000. So how is the system collecting data and how is this working? So here the central point is the gateway and the Asset Health Monitor service behind. So the gateway is continuously checking the device's health status, and that's done in an active way. So it's actively requesting device diagnostics. So in hard, let's say with a command 48. The devices will respond. So basically, hey, how are you? The device will respond, oh, I have a function check diagnostic. Okay, that will be stored in the Asset Health Monitor, and the gateway will continue with the next device and will ask, in this case, it's okay. And that's continuously ongoing. So it's scanning in a sequence all the devices that are there in the field. Of course, we open multiple connections at the same time to save a bit of time, and then we go through device by device and asking for the health status. So all that is stored in the asset health monitoring database. So how can you access that data? The most easy way is with a client, obviously, and per web page. So what you see here is the client monitor on the left side. So all you need to see the diagnostic status is a simple web browser. So we use Google Chrome here. So you enter the IP address of the gateway of the server here, sorry, of the Asset Health Monitor server, and you will be connected with that web page. So you can browse the overview. You see in one view, you see what devices are, how many devices are good, how many devices need maintenance. You can filter them, you see a list. We will go into the user interface details after that animation. You can see it a bit larger in live. And you can connect to the device. So just to access that information about the health status and the history, so what diagnostic messages had this device before, really the only thing you need is a web browser. And it's very easy to navigate because we can map the plant structure. So if you want to configure a device, so you want to change a measuring range, or you want to do an envelope curve mapping, or you want to run an internal verification and get a PDF report out of it, it's very easy to access. So you can just click the configure device button. And if on the machine you're working on, you have a client software called FieldCare installed, that software can connect with the device. So how is this working? The web server will actually trigger in the back that FieldCare will open, and FieldCare will then automatically connect to the gateway because it knows from that web page where to find it, and the gateway will patch you through the device. And now you can do heartbeat verification, and you can do a configuration or troubleshooting of the device. So the important point is here, you don't have to struggle with network controllers, path, where to find the device. So let's say in a traditional DCS or PLC environment, you would have to know, hey, this device is connected to network A, controller B, and then on the controller B, it's on the IO card XYZ, and there it's channel 5, and there we have the hard device. So usually, if you talk to maintenance people or if you work in maintenance, this is not the world of maintenance instrument technicians, most cases. It's more from the DCS PLC side, and we make it very easy to access. So you can navigate the plant structure, and with one click, you can connect to the device without having to take care about COM ports, IP addresses, baud rate settings, and whatever you need to figure to set up to connect to that device. So that's in a nutshell how it's working from a topology point of view. And I would say we just straight go into the live demonstration. So I have two systems here to show you. So one system is actually, it's in the United States. It's in Greenwood, Indianapolis, where we have our US headquarters. We have a training unit there. So this is a large process training unit with 50, 60 devices. And a part of it we have connected. So one thing I would like to show you is how easy it is to access. So you just enter the IP address of the Asset Health Monitor, and you can straight jump into the web page. So one thing we have a bit different than you may know it from other systems is that we have a plan view. So we can structure the whole instruments, the whole sites according to your real site, to your real site structure. So you're not bound by network. So you can really do this like unit A, B, C. You can say, okay, we have here a cracker, here supplies, and you can really put the structure there. As we are remote connected, that is a bit of a slow connection because I'm connecting here from Germany, and it might take 1 or 2 seconds to connect. I also have a bit more responsive system over here in Switzerland. That's why I'm using this at the moment. So as you can see, we have the plan filter. Oh, sorry. We can click on the gateway. We can select the gateway we would like to work on. In this case, I choose the Rockwell. Then we have the plan view, and we have here a location that's called Rheinach. That's the village or the city where our office is. Then we have here an area that's called FIT room. That's where the system is located. So you can also call this area ABC, unit ABC, so you're completely free. And then we have below that, we can even do kind of sub areas. In this case, with cleaning room, testing area, and production area. So if we go here, you see there are little icons like green check marks and here question mark. This is out of spec. So the most important diagnostic message will go up the line in these symbols. So if you have this on the top, you can see the most critical thing you have here is out of spec. And this is in the production area. There's a device, and that device says, okay, the predicted signal strength has a problem. So we have to check the medium menu to see if we have it right configured. And you see also, this is Endress+Hauser device. It's a Prosonic Flow B200, device revision 3, the location and the serial number. So you get all this information very easy with just 1 or 2 clicks. You can also have a look at the device history. So you see what happened here. So let's say on the 18th of May, we had this diagnostic message where the communication error with the device earlier. And you also see here when the system is running and when it's not running. It's also logged when the system is for maintenance or for what reason ever is in maintenance mode, shut down, then it's also logging. Let's say that you can clearly see when it was active or not. If we want to connect it to a device, it's relatively easy. So we just select the device. So I take this temperature transmitter here. So I see there are no alerts. I also see here everything is okay. And if I want to connect to the device, I just click configure device. So then in the background, as we explained, now field care needs to be installed on the client with all the drivers here. So we use FDD DTM technology, but we also have over 3,000 devices with DD files here. So we can also interpret DD files. So we can use both technologies in case you're a bit familiar with that. So it will automatically look for the device. It will connect. As we have here hard signals, and hard is incredibly fast with 1.2 kilobit. It can take a couple of minutes until we see all data here. So you see it's already starting building up. We're connected to the temperature device. It's Endress+Hauser temperature transmitter TMT82. Now I see the health status here, it's okay, and I can start doing diagnostics, troubleshooting, configuration, change measuring ranges, whatever I like to do with that device. And it's just one fingertip. So on the tablet, the same thing. I can easily connect. So I don't have to take care about any project files over here. Everything is stored. We can also connect that system with a central information management system so that you can store verification reports, device configuration reports in a central database on site. This is called WAM. It's available also since a while from Endress+Hauser, and those systems are also connected with each other. So another way to access the system is, of course, here from the front page. So you see we have now 10 devices that are okay, 0 devices with failure, and 1 device with maintenance required. So if I click on this one, I have this filter view here where I can clearly see all the devices that are connected to the system. And now let's call this a Monday morning scenario. So you come to your office and you want to see, hey, what happened over the weekend. So you just open that page. So the page you see here is a summary of all connected gateways. So this could be a summary of, let's say, 5,000–6,000 devices. So you will clearly see how many of them are good, how many of them are bad. But of course, you might need a bit more detailed information. So you can go down to gateway level. So you can say, okay, I only want to see those from this gateway. Then you can narrow down. So you can go down the line from a really high level top until a very detailed level. So one way, as I said, is the navigation with the areas, call this plant view. But another way is the filter, and this is a very powerful tool. So as you see here, I see all devices that are connected to the system. So I can even select how many devices I would like to see. So we have 2 pages here now with devices. And as you can see, everything is on here, but I say, okay, I'm not interested technically in the ones that are good because there's nothing I have to do. So I take them out. So I only see the ones that have a non-good status. And this is now for that particular unit. So we can also do this for the whole site. So you can see here, if I go here, this is now for the whole system with all the gateways. At the moment, there are 2 gateways connected. So with all the gateways connected. And I see a clear overview about what's going on. I can also say filter even more, so only the ones that have a failure, or only the ones that need maintenance. This can be also done by type, so you can categorize the devices into types, like analytical devices, pressure, digital, flow, and that's okay. I want to see only the temperature, or I want to take the temperature out, so it's working in, say, take them out and say, okay, I want to see the temperature, so I only see temperature devices. Or here, go for wells, positioners, flow meters, pressure gauges, and so on and so forth. So it's a very powerful tool to filter. But even more than that, if you think, oh, I quickly want direct jump to tag name that I have in mind, you can just enter the tag name in the search field, and this is really working like Google. So you enter FT, and it was FT13. Oh, I don't remember exactly what was the last number. So you just type in FT13, press enter, and now you will get the tag FT134. So this is working also if I just want to see all the FT tags, and this is working on all the fields you see here on tag, location, manufacturer, device model, division, serial number. So if I want to see all the ProMac devices I have on my site, so I have one ProMac here. If I want to see all the devices that are in the cleaning room, so then I just press clean. You see here those 3 devices now connected. And this is a very powerful tool. It's very easy to access to find the device you're actually looking for. If you don't like list views, you can also switch to label view like tiles. Then you see the same information just in a bit of different format. That might be interesting for, let's say, tablets. One thing that is important about the user interface, as I said before, this is responsive design. So as you can see, it automatically adjusts to the screen size. So if I put this in a kind of, let's say, smartphone format, so this would be a smartphone format from the web browser. So you can see that it's automatically adjusting to that view. So wherever you use it, if you use it on a tablet, if you use it on the desktop engineering stations with various screen sizes, it automatically adjusts. So we can filter, we can go through, and we can configure a device, and we can open this, and we're connected. So very easy to access. Then so we're connecting. In this case, it's a pressure transmitter. Here we go. Will take what, 30 seconds. As I said, it's a hard device, 1.2 kilobit connected to a hard remote I/O. Then this is actually will take a while. So I could do here also a documentation. Now I can pull all the parameters from the device, store it in a digital format, can store them in a central database. That database will store the data. So then, let's say if I do this during commissioning, a half a year later or a year later, someone changed something, then I can do the same thing again, and I can compare them so I can see what's the difference between as left and how it is today. And also I can store this information in digital format in the database, which enables you, if you have to replace the device with the same type, you just connect it, you get this data, it's assigned to the tag, you just download it and you load it into the device. and then you would have restored the whole device configuration with just 2 clicks. This is also a very useful tool for maintenance, to troubleshoot and to do device replacements. Also, configuration reports can be stored there, and you can access the information. So there are 2 ways. Either you're connected here to a web portal that we supply, or we can do this completely offline on-premise as well. So this is about the client, the user interface. And as you can see, compared to other DCS or asset management systems, it's very easy to access. So you can have the structure like you have it on your site here with this plan view feature. And now, how is the setup and how does it look on the server? So on the server side, you as an end user, as customer, you typically have not much touch points. So once it's set up, it's running. I'd like to show you as well a bit of what's behind. So therefore, I connect to the gateway here. As you can see, this is the traditional network topology. So we have the Rockwell communication DTMs, the factory links. This is the driver software that's responsible for connecting the devices. So you can see the system here in working, everything where you have a green line and this 2 green red this green symbols here. It's actually connected to a device, to a system, remote.io and a hard device, and getting information data. It's collecting information data in the background. So you can see here the status and overview, and you can see here the topology. So that's what you just saw on the web interface. So we have Endress+Hauser, we have Reinach, we have the FRT room, the cleaning room. So now if we want to restructure that, we can just make a new plant level. So we call this a unit and give this a name. And this is a bit of tricky with remote desktop. And now I would be able by drag and drop just sort the devices into that new structure. So after an update round, which can take around 5 to 15 minutes until the servers distributed that, you will see this also reflected automatically in the web page. So all the clients, and you can have multiple clients, like 5, 10, 20, will then automatically get that structure. So here you are completely flexible. So you can put in the same area, you can put a hard instrument, a Profibus instrument, you can put an instrument that's connected to a Rockwell, you could connect an instrument that's connected via Profinet and a hard remote.io. So here, the end user doesn't really have to worry about if this is a hard device, if it's a Profibus device, how it's connected. So that's all done here on a central point, let's say by the experts. It's also very easy, so it's automatically scanning function. So if you click here on create network, the system will automatically scan and will add the devices there, and you just have to sort them in. But that's done in one central point, and all the clients can access that automatically. So then we also have the mobile clients, and I'd like to show you how this looks like on a mobile client. Therefore, I just minimize here. A second. Here we go. So on the tablet, we have the same user interface. So this is the screenshot of the tablet. And if the system is connected, you can use that also as a remote access to the system. You can use the tablet to connect point to point with a hard device. So it's replacing a communicator. So you can go to the field, open the device, connect with a hard modem. Then you would use that play button here. You automatically connect it to the device and you can configure. So for all of you who don't know the tablet, that's it. So it's very lightweight. It's water protected, so you can take it in the rain or in the snow. You can also read it outside during sunlight, and it's available also in a classification for hazardous areas for Zone 2, and we also have a Zone 1 version. And out of the box, it's integrated as well to this. So the only thing, once it's set up, you have this remote button, and if you then navigate here through, you will see the same structure that we had. So we have also the network view, the plant view, and you will see the same areas as we just saw before, where you can click on it, the cleaning room, the production area, and the testing area, and then you can connect to the devices for troubleshoot. If you click on them, you automatically connect it to the device, and this is really just with a fingertip. So literally, so there's not much knowledge you need to connect. So it's very easy to access. Yeah, so summarizing, as you could see, the focus during the development was really make it easy to use for the people that have to use it. So we put a lot of effort in the user interface and in the look and feel, and to make it easy to access and to store data and restore data, so to connect the systems with each other. Yeah, I would say I'm technically through the live demonstration here. Taylor, I think we have a couple of questions popping up in the chat. I think your microphone is muted.
Sorry, can you hear me now?
Yeah.
All right. Thanks very much, Christian, for that demo. That was really good, comprehensive. We've got a question from David. He's asking if you can view it with a web server. So if you can type in the IP address to his PC now, would he be able to connect? And I think you already covered about if you can view it on a mobile phone or on a normal laptop.
Yeah. So this is running in the local network, so it's not on the internet. And so therefore, if you're in the local network, you really just type in the IP address and you can see the web page that's on the screen now from your system then, but it's not in the internet. So if you type in that IP address, will lead to nowhere at the moment in the internet because it's on the local network. But yes, the only thing you need to do is type in the IP address. Just do this as an example. So this is the IP address. I just press enter. Here I am. And yes, it works also with mobile phones. So the screen size is automatically adjusting. The only thing that's with the mobile phone is not possible based on the technology. This is really if you want to configure a device. So you click on that configure button. This button won't work on a tablet, an iPad, or iPhone or Android phone because you need FieldCare installed and licensed on that machine. So what we also have are customers that have then those clients as virtual machines, and they have a solution. So Rockwell has a solution for remote access on terminals. So with thin clients, and then you can authenticate yourself with an RFID badge and you get access to it. And so there are several ways to make access to that system, or you can just take your office laptop and access it. It's also possible.
Thanks, Christian. We've got another couple of questions around what the difference between the SRP 700 and the SFE 500, and then also the difference between device care and field care. What are the differences between all these software packages?
So SRP 700 is basically, it's based on field care, which is SFE 500 with an Endress+Hauser. Field care as a software is a standalone software. So that means you would have a view like, let me switch here to the server view, would look like this. And then you can connect to devices, and from here you can then configure. But this is a point-to-point kind of, so you can connect, you have it on your laptop, you have one project file on the computer or the engineering station, and then you can connect. But you cannot access with multiple clients at the same time, and you don't have the health monitoring. So with this solution, we have the monitoring of the diagnostic statuses, And the navigation is not done here in FieldCare. So you have that web page that everyone can access, that has access to that page. So you can also restrict if you like, but it's very easy to access. So SAP 700 is a client server version of FieldCare, if you want to say so. And with a centralized server that collects all the data and stores it in a centralized database, and clients that can access it. That's the difference between FieldCare as a product and the SAP 700. The difference between device care and field care. So if you have third-party devices, if you want to use the advanced functionalities like that compare feature of or before done configurations and actually configurations, for instance, that requires a field care license. So device care is, let's say, the lightweight device configuration tool that you out of the box can configure an Endress+Hauser device. If you want to use third-party equipment or do more sophisticated things, as I just said, then you need a field care license. So that's the difference between those both.
Excellent. We've got another question from Anurag. Asks, does it support Siemens PLC as well?
Siemens PLCs, let's say if it's a Profinet infrastructure, yes, we can connect to the Profinet, but we cannot route through Siemens PLCs as we can do with Rockwell. Reason for that is very simple. Siemens is locking it down. So we can go through Profibus remote IOs, for instance, because this is an open standard and open protocol. So wherever there are open protocols in place or the vendors are cooperative with us, we can do that. But a Siemens S300, S400, we cannot go through. But if there's a Profibus DP below, or if there's Profinet with hard, we can do that. In case there is no Profinet, no Profibus, or no Ethernet network that we can hook on to connect to get access, we also have the options to place modules in front of traditional IOs that strip off the hard signal and convert it to Ethernet. With that way, we can also integrate legacy installations. So let's say installations, maybe you have installations where you don't have hard at all. So there is no hard capable card of the DCS or PLC. So then we can put that in front and you can get access to that. That way, the system is also very versatile. So you can have one fits all. So let's say maybe you have legacy installations with the old Siemens and old Honeywell and some parts Yokogawa. Then you would have, first of all, to have hard cards in all the systems. And secondly, you would have 3 different systems. So you have a Siemens, a Honeywell, and Yokogawa system. So with our technology, if we even put in this hard modems channels before the IO card, we can get it, strip the hard off. If we have Profibus, we can directly connect. If we have Ethernet IP or Profinet, we can also connect to this and then go to hard devices where the remote IO. And then it's very versatile. So you can have one tool fits all in combination with that tablet that you can even go to devices that are not connected to the network.
Another question, probably leading on from there, Andy asks, if we only use the 4 to 20 milliamp signal from devices to the DCS, is it still possible in any way to collect data to the SRP 700?
So the first thing, you have to have the technology available to get the data from the field, so from the instrument to the system. And one way how you can do that is with hard. There is, however, if there is no hard in the field device is not hard capable and the IO card is not hard capable, then there is no way to get this information. In case your PLC is not hard capable, so does not have hard input cards, we can put a device in front of it to get this. But the precondition is that the device is speaking hard. That's a precondition, or have any other digital communication technology. So we also have some devices where it could connect, for instance, with Ethernet or Wi-Fi. But you have to have some technology available to get it out of the instrument, because otherwise you just get a current and then you just get technically good or not good.
Ryan asks, what is the difference between the SRP 700 solution and that of a FTT FITS or an FST IoT platform?
So let's say the SAP 700 is an on-premise solution that is not requiring any cloud connectivity. So Endress+Hauser has an IoT cloud Natillion, and we also have a health module in Natillion where you can add an edge device and you can get a similar overview like you see it on the client side. So if you have a look at natillion.endress.com at the health app, you will find something very similar to that. But of course, it's a cloud environment and it requires connectivity. So some customers say, well, we don't want to have connectivity yet, we're not allowed to, or we cannot. So then we have this as an on-premise solution. So this is working in the local network. The second thing is, besides looking at the diagnostic, we have a very strict policy that we are not configuring devices via the cloud. So we're not manipulating measurement ranges via a cloud platform. So it's a one-way street. So it's from the field to the cloud, and it's not the way from the cloud to the device. So that means if you want to configure a device, create a report, change measuring ranges and do stuff like that, you need also a local system, and that's where we see that. So this is the local system, and we also have an offering that's connected to cloud and IoT. And of course, we're working, let's say, to bring those two worlds together, but we clearly see a demand from customers that would like to have on-premise solution, and this is what you see here.
We've got a question from David. He's asking, will it be able to monitor any values?
So here in this system, we're focusing on diagnostic values. So that means diagnostic status. So we see a clear differentiation between having process values and diagnostic values. So process values we see in the domain of the control system, because you want to run the control of an inventory system to collect the data. This system is really tailored for maintenance for health and diagnostic information. However, we can also, if we know what kind of device and how to get the data, we can also monitor some values here, but we have other solutions that are better tailored to monitor, let's say, process values than this one here. So we have an offering for that as well. And we also are able, project specific, to do customizable dashboards with specific KPIs to show you more information that you can see on that web page here. So this is let's say the standard package where you can, out of the box, where you can see the diagnostics. So yes, we can do more, but we don't see this in the domain of collecting process values, because that's for the PLC or the DCS or for inventory system. We also have an offering there, and this is for, let's say, maintenance and troubleshooting.
Just along those themes there was another question from Ryan just asking, is there an OPC connector available to pass this information up to a higher system at all?
Yes, we are working on this topic. We already have some first versions, some trials running there, and stay tuned, there's more to come.
Excellent. John Paul asks, in terms of security, can the access be password protected?
So there are several ways to limit access. So first of all, you can lock down field care that you need a password to log in. To access device configuration is one thing. The second thing is there are technologies available to restrict the site to restrict the access to that web page if you would like to do that. And we can also integrate that, let's say, take a Rockwell system with FinManager, that's a client, that's a solution where you can have a server and virtual machines, and then you can restrict the access to those machines using that security. So we have a demo system in the US where you need an RFID card before you're able to see that web page. So we have basic security implemented in that system here, but everything that's more advanced, as usual, you leave this to professional providers, and then we basically be utilizing their systems. So yes, we can restrict the access to those pages, and we can implement that also in a security concept.
We've got a question from Jerry. He asks, can the client and server be in a VPN network and therefore work in multiple remote locations?
This is depending, yes, this is depending a bit on the technology we're using. So if the driver files, the communication driver files that are used to connect to the system, so if I go back to the server, so here we're using the Rockwell, the factory links DTMs. So if those are suitable, let's say, to be connected with this kind of technology, then yes, but it needs to be tested. And the main reason is not the bandwidth, like a lot of people think. So do we have 5 megabit or 10 megabit or a gigabit? The reason is actually the timing. So what you consider as a ping time. So how long does a data package need from the server and back? So usually if you're in a local network, you have ping times around 10, 12 milliseconds or less. Now, if you're in a VPN and you have this time goes, let's say you use a cellular connection that's not good and whatever, then it might be that you have around 100, 200 or 500 milliseconds of this transmission time, and that can cause some issues. So if the connectivity is stable, let's say you have a VPN fiber optic, yes, it works. We did that before. Transparent tunneling is working, but it really requires low latency connectivity and suitable technology on the driver side. So there is no general statement if it's possible or not. It really, we would have to look into that project specific.
We've got a question from Fortunate. It asks, is it possible to access field HART device through the gateway? And do you need a special card to access HART data from the device?
So yes, on the gateway side, as you can see here, there are no driver files for directly configuring a device. So we need a client to access through the gateway. So if there's a restriction on machines or clients, we can virtualize the whole thing. So we can have one computer there that has a virtual machine for the server and a virtual machine for the client. That's possible, but you need a client to access that, as in any client server system. And what was the second part of the question? Sorry,
do you need a special card to access the HART data from the device?
If you have Rockwell, we have a list of supported IOs. So the majority of the Rockwell IOs are there. The majority of the Siemens, let's say ET200 IOs are there. So the HART IO has to support this technology. FTD-DTM, it must be waitable, so proprietary solutions do not work. So the card must support it, but for Rockwell, the 7056, the 7094, the 1736, there's a long list, and the majority of the Rockwell IOs are supported by that system, yes.
We've got a question from Rain. Asks, is field care very good for flow certification and verification?
Yeah, so you can do a verification for flow meters with that system. So instead of loading the let me show you. I have recorded it up front. Instead of doing the device configuration, you can also do verification directly out of the system. So my browser. Yes, it's possible. The short version. So I'm not able to find the video. Okay. So this is how to do hardware verification. I will just go through very quick. So you connect to the device, you perform the verification. So you can check if it's okay. You can click on configure device. Fieldcare will open. By default, will open the configuration page of the device. So then you switch to the flow verification DTM, and then you can run a verification. So, and the video is 5 minutes. You can see the past verification and you have the report, and you can look that report and store it. So yes, it's possible with the solution to do that. And now with Flow, you have to change the DTM for the ENH devices, but that will change. So we're implementing now in the new DTMs. This functionality will be in the device DTM. So that means you don't have to switch between the flow verification functionality and device configuration functionality. That will be one in the future. But yes, it's possible.
We've got a question from Luke. He asks, are there any predictive health monitoring tools built into the SRP 700 health monitor?
Not yet. So we learned also, if you want to say a bit the hard way, that doing predictive maintenance is not as easy as it looks like. So yes, we can monitor diagnostic data. We also have the capability at the moment in the DNA of the system to monitor specific values, like a tuning frequency from a tuning fork, or from a vibration frequency from a Coriolis mass meter. So technically the core is there to get the data, but what we learned is it takes a lot to interpret that something useful comes out. So there is more to come from our flow division and for flow meters. But this is at the moment, it's not implemented in that solution. So we're here focusing on the principle that we say we have the intelligence in the device, so the device knows it's actually checking itself continuously. And if the algorithms in the device are saying, hey, there is a problem or there will be a problem, it's reporting that to the system. So that's the approach we have at the moment. We have a second approach, which is a cloud-based one, where we transmit all the data, the raw data from the device to a cloud, where we have some AI algorithms in the background making that kind of calculation and assessment based on historical data, process data, environment data, and a lot of other things, and then come up with a prediction. So the answer here is it's not in the system. We say, okay, if it's in the device, and if we really go to a predictive, we do the cloud-based because it has some advantages as well, because you can take data or learn from a lot of instruments and not just from a particular one.
And we've got time for one final question, just coming now. Are the changes that you make within the system automatically propagated to the DCS?
No, not to the DCS. So that's the advantage of the system as well. You not have to modify or touch the DCS at all. So that means if you make a change in that system, the topology in the plant, you're completely independent from the DCS. So you don't have to re-engineer, you don't have to touch the DCS. However, we can export the topology in some formats. Easiest one would be a CSV that you can import again back in the DCS if you want to do so. But we really had a focus that we separate the two, because maintenance people don't have to touch the DCS on the PLC. You let the PLC and the DCS do what it's best. It's controlling the process, and have a separate system for maintenance.
Excellent. Well, thanks very much for your time, Christian. It's been really good to get a lot of the questions answered that everyone's been asking. So for everyone else who we didn't get time to answer their questions today, we'll get back to you individually after this webinar. Otherwise, if you do want to ask any questions or want further information, stay on the, fill out the survey after the webinar that pops up. And then if you type in your details there or any other further questions that you might have, then we'll get back to you. Thanks very much, Christian.
Thank you very much. Also, thank you very much for your time. I think this afternoon at your place. So yeah, then enjoy the rest of your day.